it's really remarkable time that we live in.
Man, yeah, I agree. Okay, now speaking about analysis, I would like to get back to that quickly. There's a field called non-standard analysis. Do you have gripes with that field? And if so, what are they?
Look, I have a lot of sympathy for that field, but I also have some reservations also. Non-standard analysis, we can trace that back to Leibniz and Newton, with differentials and infinitesimal. And in some sense, people have been trying to get past the 17th century objections that people had to the calculus for a long time. And that's one way of doing it. And I think that's actually quite an important thing to do, because physicists and engineers love to use differential kind of analysis. We have this is sigma, and then we change it by d sigma. So now we have sigma plus d sigma, and then you treat d sigma as a small but non-zero infinitesimal object effectively. So I have my own take on this. I've talked a little bit about this, I think, in my famous math problems series, constructing infinitesimals or something. There's algebraic ways of doing that, and it's basically using matrix theory. So and we were talking about extending number fields, extending the number system so we have square roots of things. Well, similarly, you can extend number systems so that you can create infinitesimals. And from my view, this is the right way of thinking about infinitesimals. They're objects that you create out of matrices, typically nilpotent matrices that have the property that their square is 1 or their cube is 1 or some such thing. And, if you do this in the right way, then it becomes very understandable and cut and dry. There's nothing mysterious about it anymore. So I have a lot of sympathy with the non-standard analysis approach. However, the actual non-standard analysis approach, which is based on set theory and ultra filters and so on and so forth, those concepts are beyond what I would consider as something I'm comfortable with.
You're not a fan of set theory. Now, I understand the axiom of choice, but you're not a fan of ZF.
No, I'm not a fan of ZF at all.
Okay. Outline to the audience why, please.
My view is that I know there's a 20th century view that mathematics is based on axioms. So this is something I talk about a lot, but I don't think mathematics should be based on axioms. What is an axiom? An axiom is an assumption. Okay, you're making some basic assumption about what you're studying, and in my view, that's not necessary. You don't need to make any assumptions. In fact, you shouldn't make any assumptions. Just the way a scientist should not, go out in the field and have a ready-made bunch of assumptions. One should be assumption-free, and one should observe carefully, and one should be very clear about definitions. Okay, that's really important. But I don't think there's any need to make assumptions. That's just representing some kind of fundamental confusion. Now, admittedly, you have to start somewhere. So, there has to be some initial discussion as to how to set things up initially. And I think the sensible thing these days is to start with the arithmetic of natural numbers. That's, I think, more or less the consensus. That's a reasonable place to start. We don't need set theory for that. Set theory is a very attractive branch of combinatorics, as far as I'm concerned. There's combinatorics, and there's sort of data structures, and in data structures there's set theory, there's multi-set theory, there's list theory, there's ordered set theory. So there's these different, just another kind of data collection that we can manipulate and utilize for our constructions. But this idea that it's somehow the foundation of mathematics, that we should be, framing everything in terms of that, that's just not the way it happens. If you look at modern papers, you'll see that they don't actually reference ZF. Almost nobody does that. It's more a kind of, when philosophers press us, we say, okay, well, look, we believe in ZF. Now leave us alone.
There's one example in physics that I know of where the axiom of choice is used. There might be multiple, but I think it's to say that a module has a basis, and I forget exactly what.
Yeah, the axiom of choice plays a very special role. The axiom of choice is basically an embodiment of that very principle that I said that we should avoid, namely this conceit that we are able to do an infinite number of things. You're not able to do an infinite number of things, so there's no point in pretending. But the axiom of choice, puts the finger on it and says, let us all officially pretend that we can do an infinite number of independent things. Everybody agreed? Okay, we're all agreed. Okay, now so yeah, sure, that allows you to do all kinds of things, but do in quotes. You're not actually doing them. You're talking about things. Because you still can't do an infinite number of things. You can talk about it. That's all. So anything that's based on the axiom of choice is, in my view, highly suspect. And unfortunately, there's quite a lot of that floating around.
We can have another podcast just about what it means to do. I think that's a fun, just discursively, speculatively.